Welcome class to this video on Trigonometry section 5.1 to 5.3. I'm making this video to compensate for the fact that I've been absent for the last few classes and that you have a quiz fast approaching. I'm going to go over with you this practice quiz which you have been assigned today while I am absent. I'm going to go through the entire practice quiz so that you can know what you need to do and be ready for your quiz that is on Thursday. All right, so let's start off with number one. It says, for each of the following right triangles, an angle is labeled. With respect to that angle, label the sides of the triangle as opposite, adjacent, and hypotenuse. So opposite, we're going to put OPP, adjacent, we're going to put ADJ, and hypotenuse, we're going to put HYP. Okay, when doing this kind of question, easiest always to identify the hypotenuse because the hypotenuse never changes. The hypotenuse is always going to be an angle that is opposite, or sorry, a side that is opposite the right angle. Okay, so that here is my hypotenuse. Then if I want to identify the adjacent, adjacent just means next to. So it's the line that's not the hypotenuse, the side that's not the hypotenuse, that is next to the angle. So in this case, that is here. This is the adjacent side. And then the opposite side is the side that is furthest away from the angle. So that makes this the opposite side. And we can do the same thing for B. If I look here at the angle G, again, I'm going to identify the hypotenuse first because that never changes. That is the side that is opposite the right angle. And then I'm going to do the adjacent. That's the side that's not the hypotenuse, that's next to G, so I'm going to put here ADJ, and then the opposite, which is the side that is furthest away from the angle that's being referred to. In that case, it's over here, opposite. Alright, so we can do C now, and again, I'm first going to identify the hypotenuse. That's the side opposite the right angle. I'm going to then identify the adjacent. That's going to be the side that is next to the angle that we are referring to and is not the hypotenuse, and then the opposite side, which is furthest away from the angle being referred to. That handles questions like question number 1. So we can move on to question number 2. It says, for each of the following right triangles, label the angle being referred to as A. So if I look here at question 2A, I need to identify either this angle or this angle as angle A. And how I can determine which one is angle A is by looking at how the sides have been labeled. So this says adjacent here. That means that the angle A must be an angle that is next to this side right here. Okay, so obviously that means that the angle has to be right here, because the only other side that would be that this ADJ could be next to is the right angle triangle, and clearly the angle can't be that one. So the angle here that we're referring to is A. And that also makes sense for the opposite, if you see, because the side is opposite, it's the side that's furthest away, and the adjacent here is next to it. So that's angle A. So I do the same thing over here. I'm looking at this and I say which angle is next to the adjacent. Can't be the 90-degree angle, has to be this one, so that must be angle A. Again, I'm looking over here. If I look at the adjacent, which angle is this going to be next to this side right here? Well, the only possibility is that this is it here, because it can't be, again, the 90-degree angle. You can see these are very easy, and you can always just check, like, this is opposite, this is the hypotenuse, and this is adjacent to A. Alright, so hopefully those have made sense to you. Now we can look at question number 3. It says, determine the 3 basic trigonometric ratios for the indicated angles in each triangle. Put your final answers as reduced improper fractions if necessary. They're not all going to be improper, of course. If I do sine R, so that means I'm looking at this angle here, R, and I'm doing sine. Let's start by writing our SOHCAHTOA. So SOHCAHTOA, and this will help us to do this. So if I'm doing sin r, that means opposite over hypotenuse. The other good thing to do would be to label these. So this is obviously our hypotenuse for r. This is our opposite for r. And this is our adjacent for r. Remember, it's going to be different when I start doing it for p. So I'll use a different color to show that, and I'll probably get rid of the labels I currently have. So if I look here at r, and I know that sin is opposite over hypotenuse, so that means 22 is opposite over the adjacent, which is 100. Over the hypotenuse, which is 122. If I reduce to lowest terms, I'm going to divide both the numerator and the denominator by 2. And that's going to give me 11 over 61. And I chose 2 because it's the greatest common factor for 22 and 122. So that handles sin r. Now I'm going to do cos r. Remember, cos is adjacent over hypotenuse. My adjacent is 122. Sorry, my adjacent is 120. And my hypotenuse is 122. And when I then reduce to lowest terms, again, I'm going to divide both by 2. And I get 60 over 61. And I've done cos r. Now I'm going to do tan r. Remember, tan is opposite over adjacent. So that's going to give me 22 over 120. Opposite over adjacent. I divide again by 2, and I'm going to get 11 over 60. All right, so now I'm going to do sin p. Now I'm looking from p as my reference point. That means I'm going to have to change all of these because now my perspective has changed. And when my perspective has changed, actually the one that stays the same as we've discussed is going to be the hypotenuse. That's going to stay the same. But this now is going to become the adjacent. And this over here is now going to become the opposite. So now when I do sin p, for p, for sin, it's opposite over hypotenuse. So that's going to give me 120 opposite over hypotenuse over 122, which is going to give me 60 over 61. And now when I do cos p, that gives me adjacent over hypotenuse. So that's going to mean 22 over 122. Again, reducing to lowest terms is going to give me 11 over 61. And then if I do 10, which is opposite over adjacent, that's going to give me 120 over 22, which is going to give me 60 over 11 when I reduce to lowest terms. And in that case, I get an improper fraction. Okay, so that handles how we do questions like question number 3. We can move on to question number 4 now. So looking at question number 4, what I have to do is find the value of the variable in each diagram. So here, the variable is m. Now the first thing that I'm going to do is that I'm going to look at the angle that is identified. This here is the angle that has been identified. I'm now going to label my triangle based on that. Right, so I can label this as the hypotenuse. That would always be the hypotenuse, regardless of the reference point. But what's important here is to recognize that the m is opposite. It's the opposite side. And so if I should be writing down here, SOHCAHTOA, I can then now think to myself, which of the trigonometric ratios uses opposite and hypotenuse? So opposite, hypotenuse. Look, it's the first one. It's sin. So that means I then write sin 68 degrees over 1 is equal to opposite. In this case, my opposite here is m. m over hypotenuse. In this case, the hypotenuse is 11. Now, to solve this, I'm going to cross multiply and divide. So this is going to get multiplied, this is going to get multiplied. Now we know anything times 1 is just the other number, so I don't have to even write the 1 times m, it's just going to be m. And my next line is 11 times sin 68 is equal to m. m times 1, but as I said to you a moment ago, we know m times 1 is just going to be m. So now when I do that, I punch into my calculator 11 times sin 68, and I will get for m 10.199. I'm then going to round it to the nearest tenth, and I get 10.2 units. Make sure you include units. Now, if you're getting a different number than this, there's a couple possibilities. One, you need to make sure and check that your calculator is in degrees. And I've shown you how to do that before. Is in degree. And the other thing that that's a possibility is that your calculator is not forward writing but backward writing. If that's the case, I just recommend using one of the class calculators because it'll be easier for you to figure out. If you're determined to use your calculator, then come speak to me next time I see you in class and we can figure out how to use it. All right, so that handles 4a, so we move on to 4b. Again, I'm going to label. Remember, hypotenuse doesn't always opposite the right angle. But again, now I'm looking from this angle. So this here is going to be my opposite. This here is going to be my adjacent. And in this case, I'm trying to find the opposite, and I know the adjacent. So which trigonometric ratio uses... Get rid of that, not so important to us now. Which of the trigonometric ratios uses the adjacent and the hypotenuse? Well, it's right here, TOA. TOA does, so it's going to be tan. So I'm going to write tan 68 degrees over 1 is equal to opposite, in this case f, over adjacent, 25. Good, now I'm going to do my cross multiplication, and I end up getting 25 tan 68. So 25 times tan 68 is equal to f. And when I plug that into my calculator, I'm going to get f is equal to 61.877, or if I round it, 61.9 units. That handles B. Let's move on to C. So if I'm doing C, again, I'm going to label. Here's my hypotenuse. Here's the adjacent side. And I have to think to myself, which of the trigonometric ratios uses the hypotenuse and the adjacent? Here it is. It's cosine, ka. So I'm going to then write cos 15 degrees is equal to adjacent over hypotenuse, so over 1. And adjacent is 23 over d, which is the hypotenuse. So this example is slightly different than A and B. Same thing though in the sense that I start off by cross multiplying. But as you can see, what's going to end up happening here is I'm going to get d cos 15 equals to 23. Now I want to get d by itself. I'm now multiplying d by cos 15 degrees. So to get rid of multiply by cos 15 degrees, I divide both sides by cos 15 degrees. That gets rid of it from the left-hand side and will allow me to isolate the variable d. I then get d is equal to, when I plug that into my calculator, I just do 23 divided by cos 15, and I should get d is equal to 23.8113, or if I round, 23.9 units. All right, moving on to D. If I look at D, this is the angle that's been given to me. This side is opposite. This side is hypotenuse. I'm trying to find the hypotenuse. I know the opposite. Which of the trigonometric ratios uses opposite and hypotenuse? Well, if you write it down again, you can see it. So, ka, toa. And the one that uses opposite over hypotenuse is sin. So, I write sin 45 degrees is equal to opposite, which is 69, over 1 I should say there, opposite 69 over A. I'm going to do my cross multiplication, and that's going to end up giving me A sin 45 degrees is equal to 69. Now remember, I want A by itself, so I divide both sides by sin 45. And when I do that in my calculator, I do 69 divided by sin times 45, or sin 45, and I will get A by itself, and I will get A is equal to 97.5807, or about 97.6 units. All right, so that's how we do those 4 questions here from question number 4. Number 5, draw and label a triangle that matches the given information. Label both vertices and sides. So the first thing you're going to do when answering this kind of question is you're going to draw a triangle. Actually, I want to draw you a nice triangle, and I'm really good at drawing triangles, so here is my nice triangle. Oh, it's not as nice as I would like it to be. Let me do one more. That's a little better. All right, so there's my triangle. I'm going to label this side A, and then I'm going to think to myself, sin. Sin means opposite over hypotenuse. Opposite over hypotenuse. So if I go to the side opposite of A, there it is. That means that side's going to be 8. And the hypotenuse is going to be 10. So I have those 2 sides. Let me do that. So I have those 2 sides. Don't do that. All right, I'll have to leave that line there. So now I can do tan. Tan is, toa is opposite over adjacent. So the opposite we know is 8. Now I know the adjacent must be 6. There I've made my diagram that shows sin A 8 over 10 and tan A 8 over 6. All right, so let's do another one. And we're going to label this A. And if we do cos, remember cos is adjacent over hypotenuse. So that means adjacent to A must be 12, and 15 must be the hypotenuse. Remember, tan means toa, opposite over adjacent. That means that the opposite side of A must be 9. And we already knew the adjacent was 12. That's how we do this. We simply create a triangle, label the sides according to the information given to us over here. All right, 6 is find the values of the variables in the diagram. This is much the same as the previous questions we did in number 4, except that there are 2 sides that you need to figure out. And you can use the exact same angle to do that. And let's start looking from this perspective. If we look at this is our and in reference to 47 degrees, this is our opposite. So which of the trigonometric ratios uses opposite and hypotenuse? And that would be sin. So sin 47 degrees over 1 is equal to opposite over hypotenuse, which gives us 51 opposite over hypotenuse h. We cross multiply, and we get h sin 47 is equal to 51. We now want to again isolate h. To do so, we have to divide both sides by sin 47. We then get h is equal to, and when I do that, I should get 69.7337, and that means about 69.8 units. All right, now I can solve for u, and again, I can use the same angle, and just think now this is the adjacent side. And now I'm looking and I'm going to use adjacent and the opposite, because I know this opposite, and I'm trying to find out adjacent, which trigonometric ratio uses opposite and adjacent. TOA does opposite and adjacent. So I'm going to say tan 47 degrees is over 1 is equal to 51 over u. Again, I'm going to cross multiply, and this is exactly like the other question, just we're putting tan where we had sine before, and we're going to then get u tan 47. U tan 47 degrees is equal to 51. We have to divide both sides by tan 47. And then we get u is equal to 47.55582, or about 47.6 units. All right, so that handles number 6. Now we can move on to question number 7. A ladder rests against a wall. The top of the ladder reaches 15 feet up the wall and makes an angle of 53 degrees with the wall. How long is the ladder? So if I'm doing this question, I'm going to draw it out for myself. Here we go. And I know that this is 15 feet. I know that's 15 feet, and it says that it makes an angle of 53 degrees with the wall. That means the angle is there. It's not a 53 angle with the floor. It's not down here. Sorry about that. It's not down here. It's up here, an angle with the wall. Okay? So it wants to know the length of the ladder. Now, to figure out the length of the ladder, I'm going to start by labeling the sides. So I know this is therefore adjacent because it's next to this angle here. And I know that this is the hypotenuse. So I'm doing adjacent and hypotenuse, which ka, toa. Which of them uses adjacent and hypotenuse? Yes, you're right. It is cosine. So I'm going to do cos 53 degrees is equal to 15 over, I'm using L, so I put L there. And remember, this is over 1. Now I'm going to cross multiply. And 15 times 1 is just 15, so I end up with L cos 53 is equal to 15. I need to divide both sides by cos 53, and then L, when I do that in my calculator, so I should do 15 divided by cos 53, I end up with 24.9246, or L is about 24.9 feet. That's the length of the ladder. All right, so we can move on now to question number 8. And question number 8 says a storm causes some 14-meter hydro poles to lean over. One pole leans at an angle of 72 degrees to the ground. How high is the top of the pole from the ground? So you can see here, this is to the ground, so that's where the angle is 72 degrees. And it tells us that this is 14 meters. So that is our hypotenuse. Maybe I'll use a different color. This here is our hypotenuse. This here is our opposite side, and We're trying to find how high the pole is from the ground, the opposite side here. So opposite and hypotenuse. Opposite and hypotenuse. Which of the trigonometric ratios uses opposite and hypotenuse? Well, so opposite and hypotenuse. So I'm going to do sine 72 is equal to the opposite, and we'll label that to x, let's say. Opposite over the hypotenuse, which is 14. And now we're going to cross multiply. And when we do that, I get 14 sin 72 is equal to x. And when I put that into my calculator, I'm going to get x is equal to 13.3148, or about 13.3 meters. And that handles question number 8. Now we can look at question number 9. Jessica's kite string is 35 meters long and makes a 50-degree angle with the ground. What is the horizontal distance x in meters between the kite and Jessica? So again, this is my reference point. I'm going to label my sides. This is always the hypotenuse because it's opposite the right angle. And this is adjacent. This is the side that is next to the 50-degree angle, which is our reference point. Which of the trigonometric ratios uses adjacent and hypotenuse? The answer is Ka, adjacent over hypotenuse. So I then do cos 50 degrees is equal to x over 35. Be over 1. So now I cross multiply, and then I get 35 cos 50 yeah, that's just double checking that everything is right here. Opposite adjacent over hypotenuse, so yeah, it should be x over 35 is right. And now I'm going to put it into my calculator, and I get 35 times cos 50. And I get 22. Oh, sorry, I should put here x. And then I get here x is equal to 22.4976, which is equal to 22.5 meters, and that is how far away Jessica is standing from the horizontal distance created from underneath the kite. This distance here. Okay. All right. So now we're on to the last, which is matching. This is very simple. We're going to place the number for each term below in the space next to the corresponding definition. So the study of angles and triangles, which does that match? Well, that's trigonometry, so I write a 5 here. In a right angle, the length of side opposite an acute angle divided by the length of the hypotenuse. So that is opposite over hypotenuse. Opposite over hypotenuse is the sine ratio. So that's going to be number 2, right? So opposite over hypotenuse. And then here, this is opposite over adjacent. Which one is that? That's TOA. So that means I'm going to have tan, number 4 is going to go here. The side opposite the right angle in a right triangle, that's always the hypotenuse. And then in a right triangle, the length of a side adjacent to an acute angle, adjacent over hypotenuse, and that's cosine. So that is the cosine ratio number 3. Alright, so that concludes this video on your practice quiz. I hope it has helped you, and I hope you're going to be ready for your quiz that is on Thursday. Good luck. Bye-bye.